So how do we translate the algorithm that marched through the matrix by columns instead? Let's remember, the convention is to use the index I in this direction and index j for the column index of where we are. How does that algorithm work? Well, you partition the matrix and vector x like that, and then you identify the first column and the first element. You do this times that to add to what's currently in the vector. But notice that the column times the scalar is the same as the scalar times the column, and therefore we can identify this as an Axby operation. What that does is it changes these values to something else. And then you've completed through here, and now you're working right there, and so forth. So notice that this algorithm works by columns, and therefore it's the j index that is going to be the first loop that runs from 1 to n. And then what? Focusing on the second column, this is now the jth column, and we need to do the jth element of x, 12 in this case, times 2 to update the first element of y. This times the second element to update the second element of y, and so forth. That's how the Axby is implemented. And if we express that explicitly as loops, what you get is for I is equal to, for I from 1 to n, y of I has to be updated as a I comma j times x of j plus y of I, and n. If you look at this carefully and compare and contrast that with the other algorithm, all that's really happened here is that these two loops have been interchanged. Okay, now let's move on. What if we decide that only half the matrix is stored or is to be accessed? Why don't you go and change the program so that it only accesses the lower triangular part, but still in spirit marches down the columns?